Hello, calculus students, and this is our homework assignment number 3. You're definitely welcome to work ahead if you like to. Just remember that these assignments are due on Monday morning, so make sure you get that done. And we should be taking a quiz over all of this position, velocity, displacement, and distance sometime next week. I'll probably just have it on the last day. And then we'll kind of wrap everything up with this and start getting into actually making 3D models and actually doing other things with integrals. We'll get into the calculus part of it. So I'm actually going to plan on doing 2 problems here if I have enough time. And so let's go ahead and get working on this. Let me first of all switch it over and get my pen ready. So as you can see, this is basically just some type of figure that is just hanging and it's springing up and down. So as you can kind of imagine, here I'll put the picture I guess over here. It's some type of spring. And it just keeps on isolating back and forth, up and down, up and down. And the equation that they give you is that the velocity equals 4 pi cosine pi t. And that's everything that's larger than 0, and we'll get into that. But what's also important is the initial value. So let me write down the initial, and they do give that to you right there at this location, the very last part. Now, the first question asks, what is the position function? Now, this is just a generic equation. It's not asking like, what's the position at this moment of time or anything. It just wants to know, what's the antiderivative? We're trying to take velocity and just go back to, what is the position function? So the integral, if you remember doing the antiderivative, you actually have to kind of work this out backwards. Now, this does have a composite function. So we're going to have to do a function inside of a function. The u term, the inside function, is going to be pi t. If you take the derivative of both sides, the derivative of u is just du, derivative of pi t is pi dt. And then if you think of this as like a division problem, it will be du over pi. Now if I substitute everything back in here, and I'm going to kind of clean things up as I substitute it back in. I put the 4 on the outside, u, because that's my u term, and then dt equals du over pi. The pi's will cancel, and I'll end up with 4 integral of cosine of u du. Wow, I hope you can read that. Let me scroll this up a little bit. And once you take the antiderivative of this expression, the function is going to be s of t for sine of u, and u was originally pi, oops, let me write that in there, pi t. Wow, let me clean that up. Pi t plus c. Now, looking at this, you're technically supposed to go back and look at what was the initial value. Oops, I didn't mean to do that. Look at the initial value, which was 0, 0. But if you take 0 and plug it in for t and then plug it in for the solution there, you're basically just going to get back 0. So that plus c does not really have any importance. All right, sorry for the interruption. So now if I go over here and type it in for sine, oops, lay down my pen, pi t, that should be my solution there, and there's my answer. The second part of the question is just asking what's the graph look like for the first 3 intervals. So remember how to graph sine. If you remember how to graph sine, this is the amplitude, the 4. The sine pi t, well, we have to figure out what the period is. And the period on this is 2 pi over b, in this case over pi, that is the b value right there. And once you work this out, the pi's cancel, so the period is 2. That's how long it takes to complete the cycle. Sine starts at the original. Since they want you to go to 3, I'll just go a little bit further. And so I'm looking for a picture that kind of models that. Obviously, that one starts at the origin. That one starts at the origin. This one only has an amplitude of 1. This one has an amplitude of 4. Easy to kind of figure out the answer there. And the last couple questions here, what's the first 3 lowest points in the graph? So I want to know what's that point, and then the next point in the cycle, and the next point in the cycle. Well, going back to my picture here, if you know that this takes 2 units to get there and split it into 4 equal parts, that's going to be 1, that's going to be 1.5, that's going to be just 0.5 there. Well, the first low point is 1.5. They will either take integers or fractions. I'm not sure if they're going to take a decimal value, so I'm just going to go ahead and write it as 3 halves. Now, since the pattern happens, the period is 2, that means it's going to repeat that every 2 units. So if I take 3 halves and then just add 2 to it, which is 4 over 2, I end up with 7 over 2. So let me go ahead and write that in there as well. 7 over 2. And keep on adding 4 over 2, which is obviously equal to 2 still, which is 11 over 2. And there's my final solution. And really part D is the same question, but they want to know what's the high points. Well, the first high point there, as you can see, is at 0.5, which is 1/2. So let me put that in there. And then what would be the next one? The next one, just add 4 halves again, or 4 over 2, which would be 5 halves. And then just add 4 again. Oh, let me fix that. And that should give you all the solutions there. All right, let's move on to number 2. Oops, I've already worked this out, so I'm going to clear that out. And let me get a blank screen here. So finishing up here, really problem 2 and 3, very similar to each other. There's not really much of a difference. A cyclist rides, let me go ahead and write down all the key details here. A cyclist rides with the velocity, and they give you the velocity there, 400 minus 20t, and it's going from 0 to 10 minutes. That's a 10. How far does this cyclist travel in 4 minutes? Well, they just want to know what's the total distance he travels. And since we're just looking for the total distance that he's traveled, you can just do from 0 to 4, 400 minus 20t, dt, and you can just type that in the calculator and get your solution. Since none of it is really going to go into the negative region, I don't have to worry about the absolute values. If I did have some that go into the negative regions, then I would have to worry about that, but I'm not worried about it on this one. Part B is really the exact same question, but just going from 0 to 9. And again, should I worry about the absolute values? Do I need to worry about it? If I take 9 and plug it in, 20 times 9 is, 180. If I subtract that, I'm still not going to get into the negative region, so I don't have to worry about the absolute value. If you want to put the absolute value, it's not wrong. You can still do that. And then the last part here on C, they kind of ask a 2-part question here. How far has a cyclist traveled when the speed is 250 meters per minute? Well, we got to figure out how long does it take this cyclist to reach this, at what time does the cyclist reach 250 meters per minute? And once I solve this algebraically, so subtract that over, sorry, I want to subtract that, negative 150, so I subtract over 400, divide by 20, negative 20, obviously, and I get 7.5. All they're asking is what's the distance traveled up to that 7.5 minutes. And again, it's really the exact same problem there. I'm hoping that you found an integral calculator on the computer, on the internet. There are a couple out there. If you just Google integral calculator, you can find many of them. I have one posted on PowerSchool just as a tip there. Definitely take your time with it. I hope everybody's doing well and staying healthy. Thank you very much.